words and you will have to know what they mean. So make sure, maybe you can review your physiology notes so you can all read the anatomy of the bowel wall and physiology in pretty good detail. So that might be a good review. Okay, so I think of a video left to with the lower GI tract. Okay, we just covered bowel wall infarcts. Oh, I want to take a look at malabsorption syndromes. Let's talk a little bit about what we mean by a malabsorption syndrome. So if someone says a malabsorption syndrome, they might be referring to micronutrient malabsorption or macronutrient malabsorption. We're going to confine our remarks here to macronutrient malabsorption, meaning there's a malabsorption of proteins, fats, or carbohydrates in some way. Many different types of malabsorption syndromes, many different ways you can subclassify malabsorption syndromes. Typically though, in pathology, when we study malabsorption syndromes, we subclassify based on where in the digestive process the malabsorption syndrome occurs. And based on that, we can define a couple of different categories. Sometimes a malabsorption syndrome is a result of a defective intraluminal digestion, meaning within the lumen of the bowel, mostly the duodenum, the jejunum, there's some sort of defective digestion taking place within the lumen of that part of the bowel. And we have primary
I found this on the web.
Primary mucosal cell abnormalities, there's something wrong usually with the epithelial cells or something with the lamina propria. Something's wrong with the mucosal cells. That would mostly be referring to the enterocytes that line the lumen of the GI tract. Sometimes those enterocytes can be damaged. They can be damaged by bacterial overgrowth, for example, toxins that are produced by bacteria. Sometimes there's some sort of enzymatic deficiency within those epithelial cells. That will be classified as a primary mucosal cell abnormality. Sometimes the surface area through which nutrients are absorbed has been reduced in some way. That can be caused by, for example, destruction of the villus architecture of the mucosa, or perhaps even the architecture of the Purkinje circularia of the submucosa. Whatever be the case, the surface area has been reduced, and so it's more difficult to absorb nutrients. Lymphatic obstruction. The lymphatic system is instrumental in absorbing a lot of fat-based nutrients. If you've ever seen lymphatic fluid, it's chylous. It looks like milk, and that's because it's got a lot of suspended fatty molecules in it. So anything happens to the lymphatic system gets obstructed. Usually it's going to present with a malabsorption syndrome, primarily of fatty molecules, and that results in something called steatorrhea, a diarrhea characterized by high content of fat. And then, of course, we have various infectious forms of malabsorption. Everybody's experienced this one. And then we have iatrogenic causes. Iatrogenic meaning something that we do as doctors has caused the malabsorption syndrome. Here we're going to be talking about examples of all of these. Let's just take a quick look at some examples of each category. So defective intraluminal digestion, again, something's going on. The lumen of the bowel, within the lumen of the bowel, we're not digesting things properly. A common cause of that is pancreatic insufficiency. The exocrine pancreas isn't making sufficient volume of pancreatic enzymes. This can be a common problem. And as a result of pancreatic insufficiency, people get bloated. They have usually steatorrhea because the pancreas is instrumental in making things like lipases and phospholipases that break down fats. Without those pancreatic enzymes, very little is going to get absorbed. Pancreatic insufficiency can be caused by things like chronic alcoholism. Primary mucosal cell abnormalities. The mucosa, the enterocytes that line the lumen of the bowel, they catalyze what we call the terminal stages of digestion, meaning the final steps in digestion. Those things are catalyzed by enzymes that you usually find in the enterocytes. For example, Within the enterocytes, you find the enzyme lactase. Lactase is an enzyme that breaks down the disaccharide lactose. Lactose is a disaccharide. Disaccharides cannot be absorbed. In order to absorb any kind of sugar, you have to break down the disaccharide into its individual monosaccharides. So lactose, opposed to glucose and galactose, you need a lactase to cut the bond, that sugar bond, so that you liberate the individual monosaccharides. Only then can you absorb it. If you can't break down lactose, then lactose remains in the gut and doesn't get absorbed, and not only that, but the bacteria thrive on it. You get overgrowth of bacteria, and that damages the epithelium even further, and you get this lactose intolerance type of malabsorption syndrome. Reduced small intestinal surface area, again, very often due to destruction of the delicate villus architecture of the wall. You know about this one, celiac screw, that's that gluten-sensitive enteropathy. People are sensitive to a specific protein called gliadin that's found in wheat. Okay, that incites an inflammatory response when people are sensitive to it, and it destroys the villus architecture. Lymphatic system sometimes is obstructed by lymphoma. Lymphoma will obstruct that lymphatic system. You're not absorbing fat, and of course we got a lot of infectious diseases and iatrogenic causes. Sometimes you have to perform some type of bowel resection. Maybe there's a bowel infarct, and that part of the bowel has to be resected in accordance to vascular perfusion territories, and that might leave a person with loss of considerable surface area, and we call that short gut syndrome. Maybe they can't absorb very well. Okay, so those are some of the different categories. We're going to take a look at some specific examples now. Let's first take a look at chronic pancreatitis. Chronic pancreatitis, this is something that is commonly in alcoholics. We'll look at the mechanism by which this occurs a little later in the lecture, but someone is an alcoholic. The secretions of the pancreas become very thick, very viscid. And it is a viscous fluid that tends to form concretions blocking a lot of the ducts in the pancreas. When you block the ducts in the pancreas can't excrete its digestive enzymes. Now, those digestive enzymes are usually synthesized in an inactive precursor form. They flow through the ducts of the pancreas, they're introduced in the duodenal sweep, and only in the duodenal sweep will they be activated. But since the little passageways of the pancreas are occluded, those enzymes kind of stick around, and inevitably they get activated, and they start digesting the pancreas. Usually, it's a very slow process. The pancreas gets digested and scars down as a result. Sometimes it can be an acute process where the pancreas develops a significant amount of necrosis at once. The result is acute pancreatitis, but very often with alcoholism, the process is very slow, and we call it chronic pancreatitis because it's a long, prolonged process by which the pancreas gets digested and scarred. Ultimately, as the pancreas is digested, you lose the acinar cells that produce those exocrine pancreas enzymes. And eventually, there's not enough pancreas to produce enzymes, and so you develop pancreatic insufficiency. Again, the most common cause is chronic pancreatitis, and that's usually caused by alcoholism. Now, when you can't produce the digestive enzymes, very few of the macronutrients you ingest are going to be absorbed, and that's going to result in profound bacterial overgrowth. That's going to lead to a lot of foodstuffs that are osmotically active left in the bowel. It's going to draw a lot of fluid. Bacteria are going to overgrow. They're going to secondarily damage the mucosa. What nutrients, what few nutrients you could absorb, is not going to be absorbed anyway because now the mucosa is damaged, and it's going to result in some profound diarrhea that's characterized by a heavy loss of fat. So it's going to be typically a steatorrhea type of malabsorption syndrome. It's difficult to diagnose chronic pancreatitis unless it's really progressed to the end stages. And so typically if we have an alcoholic that complains of a chronic malabsorption syndrome, we have a good reason to think that's chronic pancreatitis, so we'll have to work that from there. Ultimately, if you want to assess the efficiency with which the pancreas is making digestive enzymes, you would measure one of those enzymes in the stool. Typically, the one we measure is elastase. The elastase enzymes produced by the pancreas. There should be a certain amount of elastase in the stool that survives the whole digestive process that you can measure. If the elastase activity is very low in the stool, then you've got your diagnosis of some pancreatic insufficiency. Any questions on pancreatic insufficiency? All right, let's take a look at celiac sprue. Okay. The word celiac sprue refers to some sort of primary malabsorption syndrome. Celiac sprue, you probably know better as some sort of gluten-sensitive enteropathy. Some individuals develop a sensitivity to a specific protein found in gluten. It's called gliadin. Gliadin. When people develop this sensitivity to gliadin, the immune system recognizes gliadin as a pathogen. And so every time they ingest this gliadin protein, the immune system reacts by attacking the gliadin with IgA antibodies. These IgA antibodies are secreted into the bowel. They incite an inflammatory response against the gliadin, and this ultimately results in secondary damage to the delicate architecture of the mucosa of the bile. It eventually destroys the villi, particularly in the duodenum as well as the jejunum. When that villus architecture is destroyed, there's insufficient surface area to absorb nutrients, and people develop a malabsorption syndrome associated with the ingestion of any food product that contains gliadin. Now, there are a number of theories that have been proposed to explain why an individual develops a sensitivity to gliadin. But ultimately, if they do develop a sensitivity to gliadin, it's the result of IgA antibodies being produced, causing this secondary damage to the bowel, resulting in the loss of its villus architecture. And so, gluten-sensitive enteropathy is characterized by a degeneration of villus architecture. In the first parts of the small bowel, we call it villus atrophy.
At what stages of life is this gluten sensitivity usually developed? Is it more prevalent in kids, or could it happen in 30s, 40s, 50s as well?
I don't know the specific peak prevalence, but I would imagine that because it is associated with certain HLA types, it can develop at any time. To some degree, it's going to depend on the exposure of the individual to gliadin.
Okay.
But I can't give you a specific, I actually don't know the stats, which is prevalent. So the main characteristic feature of a gluten-sensitive enteropathy is this villus atrophy. It's destruction of the villi caused by secondary damage. So take a look at this. It's particularly prominent in the jejunum. Let's first take a look at normal villus architecture in the jejunum. So this is a section through the mucosa of the jejunum. You can see the lumen is over here. And there's the section through the mucosa. And you recognize the composition of the mucosa. We have the epithelium, we've got the lamina propria, and we've got the muscularis mucosa right here. Those three layers collectively are referred to as the mucosa. Now you notice the architecture of the mucosa is such that the lamina propria is sent up in folds, resulting in these projections. These are the villi, of course. The villi are there, presumably specifically to increase the surface area of absorption. Everything here looks good. You can see the villi sticking up. You actually see some crypts over here. If you look within the villi, you can see the villi are vascularized, lots of blood vessels in there, lots of lymphatics in there, that's for absorption. You'll also notice in the mucosa, scattered throughout the mucosa, you've got some white blood cells in there. That's part of the normal physiologic inflammation of the bowel. You need that physiologic inflammation to prevent any symbionts here in the lumen of the bowel from invading into the mucosa and causing problems. If they were to do so, you've got on-site and sentinel cells that will take care of the problem. That's all normal physiologic inflammation you see there. Nice delicate architecture. Someone sensitive to gliadin, when they ingest gliadin, it'll trigger a secretion of IgA antibodies. The body thinks it's being invaded by some sort of enteric pathogen. And so IgA antibodies can be introduced. And these IgA antibodies are going to complex with gliadin and other protein and complexes with, and it's going to incite an inflammatory response. And the inflammation is going to destroy this very delicate architecture you see here. So that's what normal looks like. This is what villus atrophy looks like in someone with a gluten-sensitive enteropathy. Again, you can see a section through the mucosa. There's the lumen of the bowel there. That's the mucosa. What's left of it? You can see the epithelium here. There's the lamina propria, muscularis mucosa here. You can see crypts in here, but where are the villi? The villi have all been destroyed by an inflammatory response. Okay? You can see evidence of this inflammatory response. If you look within the lamina propria, you can see inflammatory cells. Now, certainly a certain density of inflammatory cells is normal. It's part of the physiologic inflammation. But look at the density of these inflammatory cells compared to the density of inflammatory cells you have here. There's a greater density than you can account for by normal physiologic inflammation alone. So there are far more white blood cells here than you should be able to see. That's the pathologic inflammation triggered by the IgA antibodies. And that is the pathologic inflammation that completely destroys the delicate villus architecture here. So now this person has a decrease in surface area. That's not going to go well for them absorbing nutrients, so they're actually going to develop a malabsorption syndrome that occurs in association with ingestion of gliadin. Okay, any questions on this? Let's talk about the pathogenesis of this condition. Again, a number of theories have been proposed. Some of these theories have significant substantiating evidence, but I'm going to present to you the theory which is currently the most favored. A number of theories that have fallen in and out of favor. The current theory that is most likely explain the pathogenesis of this condition involves an enzyme found in the bowel wall called transglutaminase. There is an enzyme in the bowel wall called transglutaminase. It's just an enzyme that transfers an amino group from one protein to another. Normally it functions just fine. However, in some individuals, gliadin will complex with this enzyme called transglutaminase. And when the gliadin complexes with this enzyme, apparently the aggregate is antigenic enough to incite an inflammatory response, an abnormal inflammatory response. And the body makes these IgA antibodies against this aggregate. Now, it only works when the gliadin and the transglutaminase form an aggregate. The gliadin alone actually is not enough to trigger an antigenic response. Okay. The transglutaminase itself is not enough to trigger an immunologic response. But you put the two together, all of a sudden this complex is mean looking to the immune system and makes antibodies against it. Let's take a look at how this works. And here is a diagram showing you the proposed pathogenesis of this gluten-sensitive enteropathy. Again, we have this enzyme, it's called tissue transglutaminase. All it does is switch amino groups from protein to protein, one of which could be gliadin. Now, in and of itself, it is not antigenic enough to trigger an immunologic response. Gliadin is this peptide that people sometimes get sensitive to. Alone, the gliadin peptide is not antigenic enough to trigger an immunologic response. However, when the gliadin complexes with this tissue transglutaminase, apparently it is antigenic enough in some individuals to trigger the production of IgA antibodies. And from this point forward, every time the individual ingests gliadin, gliadin will complex with tissue transglutaminase and antibodies will attack. But because of the considerable immunologic response, not only does this complex get attacked, but a lot of the tissues in the area get attacked, and there's a lot of secondary damage, and that results in degenerative changes to the villus architecture, and you get villus atrophy. Okay, let's talk a little bit about the presentation. So people will develop chronic diarrhea as long as they are ingesting gliadin. The stool tends to be voluminous. That's because its macronutrients are not being absorbed. It is malodorous, but it will have some fat in it. There's a lot of cramping, distension, of course, flatulence associated with all the different malabsorption syndromes. The workup, serology, you can substantiate a diagnosis of gluten-sensitive enteropathy based on the history of developing diarrhea and associated with ingestion of anything containing gliadin, but you can also substantiate your diagnosis immunologically by establishing the presence of these IgA antibodies. You do that just by measuring titers against things like gliadin. Now, if you measure antibodies against gliadin, that will work, but it's not the most sensitive way to detect this condition. Actually, there's some other incidental antibodies that are produced, and the antibody which seems to be most sensitive and specific to this condition would be anti-endomysial antibodies. Remember the endomysium, that's an enchefment around the individual rhabdomyocytes. For whatever reason, this condition is associated with antibodies directed against that enchefment. Okay? That seems to be pretty sensitive and specific for this condition. Now, of course, you can establish the presence of anti-gliadin antibodies as well, but again, you're at a slight disadvantage for sensitivity, and that's why we would prefer to measure these anti-endomysial antibodies. You can get both, of course. There is one important thing that you must remember if you are going to diagnose this condition immunologically. Sometimes patients know that they're sensitive to gliadin, and as a result, they will abstain from eating anything containing that protein. If they do that long enough, the antibody titers will drop. And if you attempt to establish a diagnosis of gluten-sensitive enteropathy in an individual who has abstained from anything containing gliadin, you'll get a false negative. The titers will have dropped by the time you measure it. And so if you're going to diagnose this condition immunologically, you have to ask the patient to ingest foods containing gliadin. That will increase the production of antibodies. If they are being produced, you can document the increase in antibody titers. That's the only thing tricky about this. Once you've established the diagnosis, you can get them off the gliadin diet, and the villus architecture in the bowel will regenerate, and they shouldn't have any trouble. Of course, they can't eat things with gliadin in it, which considerably restricts their diet. Okay, any questions on that? How many people here know some individual with gluten-sensitive enteropathy? Well, that's, yeah, quite a few. Has it truly been documented as a gluten-sensitive enteropathy? How did they die?
I have, like, on one side of my family, they all have celiac. So, like, anytime they try to eat anything, it's real scary. But, yeah. It's, like, genetic for them, I think. Because it's, like, the parents have it, and then all of their kids got it. And it's, like, their grandparents had it as well.
That's a common history. There's usually a familial pattern, and that's because certain HLA types, human leukocyte antigen types, HLA types, are associated with various types of autoimmune diseases, various types of diseases. So there is a strong genetic component to this. All right, anything else? Okay, we got a few malabsorption syndromes there listed, they're grayed out. I don't think you're gonna see those on your boards. The last one we wanna mention here is lactose intolerance. That's a common one. Everybody, to some degree, has lactose intolerance. It's a question of just how much lactose you can tolerate before you develop a malabsorption syndrome. Lactose intolerance tends to affect adults. When a child is born, usually they can handle lactose quite easily, but as we age, we lose that ability to break down lactose. Lactose is a sugar primarily found in dairy products, milk. Normally, just for a child, it's a very easy sugar to break down. It is a disaccharide composed of monosaccharides glucose and galactose. You have plenty of lactase activity. That lactase activity can just break it down to monosaccharides. You can absorb the monosaccharides. You cannot absorb the sugar when it's in disaccharide form. The enzymes that break down the disaccharide into the individual monosaccharides are found in the enterocytes, right at the microvillus brush border. There is an enrichment of lactase activity. You should easily be able to break down the sugar. However, as we get older, we seem to lose the expression of the gene that encodes for this enzyme lactase. And the amount of lactase activity goes down. It may be completely gone in some individuals. Other people actually retain a certain degree of lactase activity. Whatever be the case, if someone overindulges, ingests too much of this sugar lactose, then you overwhelm the enzyme capacity to break it down, and there's a residual amount of this disaccharide sugar that remains in the bowel. This causes the bowel flora to overproliferate, and that causes secondary damage to the mucosa, and that results ultimately in a malabsorption syndrome. The symptoms include things like cramping, distension, explosive diarrhea, flatulence, all associated with the ingestion of dairy products. Now, very often, to formally diagnose this condition, what you would do is you would challenge the individual with a critical amount of lactose sugar, and you would document the bacterial overgrowth in response to that. You can document the bacterial overgrowth by monitoring the amount of hydrogen in the individual's breath. When there is bacterial overgrowth, that bacteria makes hydrogen, we absorb it in the bloodstream, and we'll expel it in the breath. So you can document an increase in the amount of hydrogen in the breath in response to a lactose load. That's how you would formally diagnose it. Do we formally diagnose that all the time? No. We typically come to a tentative conclusion that person has lactose intolerance just based on history. I've been eating ice cream, or drinking milk, or whatever, something dairy, and I developed diarrhea. Okay, that's typically as far as you're going to go. If you'd like, you can refer them for a lactose challenge. It's unpleasant. It's at least for them, and you can document the increase in hydrogen. Okay, any questions on that? Yes?
We were told in another class that if you give babies milk, they hemorrhage from the inside.
If they what?
If you give babies milk, like actual just like regular milk, that they hemorrhage from the inside. Is this?
Hemorrhage from the inside.
Yeah.
I mean, cow's milk?
Yes, cow's milk.
Cow's milk. Is that in conjunction with some other pathology or?
No, no, it's just that because we're generally lactose intolerant according to this sort of train of thinking.
Oh, yeah, if a child is lactose, if they're congenitally,
That, yeah, that would make
yes.
sense, but
Talking about children under the age of 1 not having whole milk.
yes, I can see that hemorrhaging, they would probably, that would be due to mucosal damage, they probably have erosions, and they when I think of hemorrhage, I think of more of a more brisk blood loss, but yes, they would hemorrhage, they would bleed into the GI tract, and that would be due to erosions.
And that would be like before 1 year, like, or just before 1 year of age? This applies to babies?
I'm not quite sure of the timing, but if they're congenitally, they have a congenital absence of lactose, or lactase, it should be from day one.
Okay.
They should have symptoms of malabsorption from day one.
Thank you.
Most of the lactase deficiency is acquired, it's not congenital. Okay, anything else on that? Do you know anything else about it?
And just know pediatricians generally tell you not to give your child whole milk, at least the age of 1, formula.
Okay. And that's, prior to the age of 1, they just want being breastfed.
Either breast milk or formula based.
Yeah, so, it's, prior to the age of 1, breastfeeding is important for immunologic support, even immunologic support, is the passive immunologic protection. I can see why I can see multiple reasons why someone would say that. Anything else? Okay. Alrighty, so, let's talk about inflammatory bowel diseases. This is a condition that can also result in malabsorption. However, because it is a problem that develops as a result of a dysregulation of normal physiologic inflammation, we usually talk about it in a separate category. It does cause malabsorption syndrome to develop. Let's talk about a few generalities about these inflammatory bowel diseases. We call them inflammatory bowel diseases because the most prominent signs and symptoms are associated with the GI tract. However, they are systemic diseases. They affect multiple systems, and they're also associated with numerous extraintestinal signs and symptoms. Again, because the most prominent features involve the GI tract, we call them inflammatory bowel diseases, but they're system-wide diseases. Someone with an inflammatory bowel disease would not only have GI problems, but they'd also have things like rashes and types of arthritides. They can have problems with vision. It's a system-wide disease. But again, most of the symptoms involve the GI tract. The main problem with these inflammatory bowel diseases is that there is a problem with the balance of normal physiologic inflammation. Physiologic inflammation of the bowel is controlled by numerous factors, some of which upregulate the physiologic inflammation, some of which will downregulate the physiologic inflammation. If the physiologic inflammation is upregulated to too great a degree, the normal physiologic inflammation will start damaging the bowel wall architecture. And this culminates in some form of inflammatory bowel disease. That seems to be the principal problem in which someone develops inflammatory bowel disease. Now, of course, there are a lot of other factors involved. And again, HLA types play an important role in this. And so, since the HLA types are genetically encoded, very often when you're dealing with someone with inflammatory bowel disease, you will find that that individual has some sort of family history of inflammatory bowel disease. Some sibling or some sort of relative has documented inflammatory bowel disease. Okay, let's take a look at some of the different types of inflammatory bowel diseases, how they present. All these bowel diseases, of course, are going to present with some sort of malabsorption. These bowel diseases are usually characterized by a remitting, relapsing pattern. That's how they present most often. A person will quite suddenly develop a malabsorption syndrome characterized by not only diarrhea, but blood and mucus in the stool. They'll have that malabsorption maybe for a few days, a few weeks, and then it'll resolve on its own, even if it's not treated. And then maybe a month later, they'll develop another relapse, and they'll experience bloody mucoid diarrhea again. And once again, that'll resolve. Sometimes these episodes just occur for no reason. Sometimes the episodes can be linked to emotional stress or some type of infection, or perhaps even some sort of type of food that will trigger a relapse. Whatever be the case, most of these instances of inflammatory bowel disease are characterized by a remitting, relapsing pattern. All right, let's talk about the two forms of inflammatory bowel disease. So we have these two forms of inflammatory bowel disease. One's called Crohn's disease, the other is called ulcerative colitis. Both of these are caused by an imbalance of normal physiologic inflammation. Something happens to upregulate the physiologic inflammation, and that causes secondary damage to the bowel. Okay. Let's begin by talking about Crohn's disease. Crohn's disease, again, is a systemic disease. It is a disease characterized by a non-necrotizing granulomatous inflammatory infiltrate. When this inflammation affects the bowel, usually it has a transmural distribution. And so Crohn's disease, you should remember, is characterized by a transmural, non-necrotizing granulomatous inflammatory response. Crohn's disease can affect any part of the GI tract, anything from mouth to anus. However, the most likely region of the bowel it's going to affect is the terminal ileum, and as a result, Crohn's disease has an alternative name. It's called terminal ileitis. Terminal ileitis. Okay, let's take a look at some of the features of Crohn's disease. Let's first take a look at the anatomic distribution of inflammation in the bowel. We got a little depiction of the bowel here. Okay, large bowel. You got the cecum here, and then you can see the terminal ileum here. Now again, this disease can affect any part of the bowel. Most commonly, though, it affects the terminal ileum. When it does affect the bowel, it usually affects the bowel in discrete, isolated regions. These pattern of areas that are affected are referred to as skip segments. Okay? The areas affected are discontiguous, they're not connected to each other. And the areas affected, of course, have these intervening normal sections of bowel. These intervening normal sections of bowel are called skip lesions. Skip lesions. They're not lesions, they're actually normal segments of bowel. So you got this discontiguous pattern here, characterized by segments of bowel that are affected, and you've got these intervening skip lesions. An unfortunate term. It refers to the normal regions of bowel. Okay, let's take a look at a section of bowel that is affected. Okay, here we have a longitudinal section of the bowel. This is a depiction of one. You can see we've got a central area of normal bowel flanked on either side by affected areas of bowel. Take a look at the normal bowel, the way it's been depicted. You can see you've got normal mucosa here with lots of folds. You've got a normal bowel wall architecture, and it looks like you've got the normal patency of this bowel. Presumably that bowel is fully functional, characterized by normal peristaltic action, normal patency. But this part of the bowel is flanked on either side by these areas of bowel that are affected. Areas of bowel affected, you'll notice, have a thickened wall architecture. They also have a strictured lumen. This part of the bowel is not as patent as the normal part of the bowel. There are going to be considerable difficulties with motility in this area. And of course, because the bowel is strictured, there's going to be considerable difficulty moving fecal material through this bowel. All right, if we take a section through these areas of affected bowel, look at it in cross-section, here's what we might see. We can see the lumen of the bowel here, and again, we see the thickened bowel wall architecture. We can recognize the different layers of the bowel wall here. We've got the mucosa, we've got the submucosa. There are the two layers of muscularis propria, and there's the serosa right here. And surrounding everything, we've got some pericolon fat. Now, I mentioned before that this disease is characterized by a non-necrotizing granulomatous inflammation that has a transmural distribution. That inflammation goes right across the bowel wall. It can damage the bowel wall throughout its entire thickness. As it does, it can create these very deep fissures in the bowel wall, you can see here. Sometimes these fissures will actually open up from the lumen to the outside of the bowel wall, and you have this patent pathway communicating the lumen with outside the bowel wall. These communicating passageways are called fistulas. And so Crohn's disease is characterized by the formation of fistulas due to the transmural distribution of the inflammation. Sometimes these fistulas will just open up and communicate the lumen of the bowel with the peritoneal cavity, in which case the person will probably develop an infectious peritonitis. But sometimes, more likely it can happen, the bowel hits up against the abdominal wall. And as the inflammation eats its way through the bowel, it actually fuses part of the bowel wall to the abdominal wall. And when the inflammation is eating its way through the bowel wall, it inadvertently eats its way through the abdominal wall, resulting in a fistula that opens up to the surface of the skin. Those are called enterocutaneous fistulas. Enterocutaneous fistulas. They are nasty looking. They look, just looking at them, they're all red. They look like they hurt. They're actually productive of fecal material. Fecal material ooze out of these enterocutaneous fistulas. And again, these fistulas form because the inflammation is transmural in distribution. It allows it to eat right through the bowel wall. Okay, let's have a look at some of the damage done to the bowel by this Crohn's disease. Okay, well, most of the time Crohn's disease affects what part? The terminal ileum. That's why it's called terminal ileitis. So let's take a look at a section through the terminal ileum. Here's the normal terminal ileum here. It's a section we have here, staying with HV. Again, there's the lumen. There's the wall of the bowel. And you can see all the different layers of the wall of the bowel. You can see we've got the mucosa right there, characterized by the villus architecture. There's the submucosa right there. And you can see the submucosa is thrown up into folds. We call these plicae circulare. That's what the PC stands for. And below that, you can see the two layers of the muscularis externa, also known as the muscularis propria. That's the inner circular layer. And that's the inner circulator, CM. And you can see the outer longitudinal layer. And investing it, you can see the serosa. Okay? Perfect, beautiful architecture. You can see the normal physiologic inflammation in the terminal ileum. If you look in the mucosa, you can see the mucosal associated lymphoid tissue, or what we call MALT. Short, mucosal associated lymphoid tissue consisting of the Peyer's patches. Recognize the Peyer's patches, they're just little follicles of lymphocytes and macrophages there. Again, that's all normal, that keeps the symbionts in check. Okay, submucosa looks good. Okay. And of course, muscularis propria should be always free of inflammation. Even physiologic inflammation would be abnormal in the muscularis propria. Architecture is perfect, looks good. Okay, if that's what normal terminal ileum looks like, this is what Crohn's disease does to the terminal ileum. Again, this is a little different orientation. We got cross section through the terminal ileum. Again, there's the lumen right there, and you can see the bowel wall architecture. You can see the mucosa, or what's left of it, right there. You can see the submucosa. There's the muscularis propria, and you can just barely make out the serosa here. Look at the mucosa. No villi at all. They've all been destroyed by the inflammation. Look at the submucosa. Where are the plicae circulare? They've been all destroyed by the physiologic inflammation. You'll notice there are also significant defects in the mucosa. If you look here and here, there's ulcering defects that extend down into the submucosa. That's due to the transmural inflammation. It eats its way right through the bowel. In fact, these ulcerations can extend right down to the surface of the bowel, creating a communicating fistula. They haven't reached that point here, but they can do that. Now, if you look at the submucosa and muscularis propria, you see these blue patches. Anybody know what those are? What's that?
Macrophages.
They're, yes, that definitely include that, and what would you call them? Aggregates. I'm asking, I'm not saying, what would you call these aggregates? They consist of macrophages, lymphocytes, those are the granulomas. So remember that inflammation is granulomatous and it's transmural. You can see the granulomas here. Where do you see granulomas over here at the submucosa and muscular propria? Nowhere. Over here you can see, look at this, look at the granulomas, they're everywhere. Transmural distribution of granulomatous inflammation. And that is the type of inflammation that will allow the formation of these fistulas. And so important things to remember about Crohn's disease, terminal ileum, transmural granulomatous inflammation, fistulas. Okay, why don't we take a break here and then we'll continue on with the